Hello and welcome to this video where we're going to be talking about how to load data from a file, cleaning it up to make it look nice, and saving it. We're also going to be talking about long to wide data sets. That's sort of part of the cleaning part and plotting and stuff like that. So let's just dig into it. As I said, you're going to learn how to load and save data and cleaning it, like the base parts of data cleaning. So first we need our packages, we need our pandas, and we sort of also load matplotlib for plotting later on. A check you can sometimes do is to use the packet os for checking whether you have the right folders basically and the files you're gonna need. So what this does is to os.pad does is directory data, sort of checks if you have a directory called data, and the directory is just the file path, and it's relative to where you are. So we are in this data, make this a bit larger, data load and clean save folder, and that has a subfolder called data. And then you just check whether or not this is true, whether this folder exists. If it does, then nothing happens. We also check whether or not these two files are available inside data. These are data files we're going to be working with later. And sort of when we can see that they are here, and when we run this, it's sort of also, there's no error, so the assertion is true. We can also print everything, all the available files in a folder using list directory, and then choosing the folder. Okay, so reading in data in pandas in Python is like extremely, there are a lot of good functions for doing it. It's not extremely easy. But it's like there's always a function for reading a specific file type. So here's sort of an example. CSV is a very common file type. SAS files, Excel files, Stata files. Parquet, which you might not know about, is a file type which is a bit more memory efficient than all of the above. So it can be faster to work with if you're just using Python anyway. Sort of transferring files between Python scripts. As I said, there are many more. You can just sort of search them. They all sort of have read underscore whatever file format you want to load as the name. So you can try to guess. I would Google first, but it's also possible to get. Two methods we're going to be using a lot is when you have a data frame, you can write a dot head and then a number, and then you just sort of show the first 10 in this example rows. You can also write sample, and then you take 10 random rows. This can be nice when working with a very large data set, which you can't really look at it all at once. Then you can just select, I want to see the first 10 rows, or I want to see 10 random rows to see if like does everything look right in these randomly selected rows. So the data we are going to be working with today is some data that I've downloaded from DST's website manually. You will also learn at one point how to sort of fetch data from the API, but not in this video. So now we're gonna see, okay, how I just download the data manually, and now we're gonna see how it looks when we just sort of use the function read Excel and load it. And as we can see, it does not look very good. There's like all the column names are just called unnamed, and there's a lot of non-values, and so these values don't really make any sense. So this data set, I should say, is the employment rates in different municipalities and regions in Denmark. And you can sort of across years from 2008 to 2021 was the latest, and you can sort of see that something is not quite right. So you have the years here in the second row, and a lot of non-values, and sort of all these values are totally, it's messy, which is what happens when you read files. So we need to clean it up. We can also sort of, it's messy, but it's also sort of what the Excel file looks like. So if I find the Excel here, we can open it in VS Code. You can also open it normally, and you sort of actually maybe it's okay. Doesn't matter. Yeah, you can see that the Excel file itself is also kind of unordered. Normally when in Excel, then you can just sort of take it from here, and then that's the actual data set we want. Okay, so how do we read this in? The easiest thing is to skip the first two rows, because we can sort of see that there's no really any information that we want in the data set, as long as we we know that it's percentage terms, and we know all this. We know where we download the data from, so we kind of know this information, and some of it is not quite correct because it's just by region. Because of the way it's been downloaded. Alright, so we can use the skip rows argument to skip the first two rows when loading the data. Okay, already now it looks quite a lot nicer. We have the years sort of as columns, and then we have all our data here, and we have all the areas, regions, and municipalities. And then we have the first four rows here, which are sort of a lot of non-values and just a little bit information about what the data is. So it's the employment rate for 16 to 64 years old. And we don't really want this in our data, so we want to drop that. And for that we can use the method called drop behind the data frame. That's sort of the most direct ones. So you just have to have a list of the names of the columns you want to drop. So they're called unnamed 0, 1, 2, and 3. And instead of sort of writing that manually, you can do that like this. We can sort of use Python list comprehension to create a list that's the same as this, just create it a bit easier. Instead of having to write everything. Yeah, and then you just basically write, you have your data frame, then you use the drop method, a list of the columns you want to drop, and then you want to use axis equals to 1, because that means you're looking at the columns. You can also drop individual rows using the method, but we're not doing that now. And then one way to do it is to write in place equals to true. Pandas has a lot of methods which has this argument. And what this does is that instead of the method returning anything, it just changes the original data frame. So you can also, so this does what we expect it to do, so the original data frames are dropped. Another thing, if we load this again, then another thing we could have done would be to sort of write this and create, sort of replace the old data frame with a new data frame where the columns has been dropped. That would be like this. Because if you don't write in place equals true, then the default value is false, and then instead of changing, maybe I should have done it like this. Sort of instead of changing the original impl data frame, which still has these old columns, then it sort of just returns a new data frame. It depends on who you ask, whether they think that one is better than the other. Sort of, I generally like just using in place because sort of it looks a bit nicer, and you're not always overwriting old data frames. Yeah. So another way of deleting would have been to simply write delete or del and then each column out. This can sort of, if you have a lot of columns, that can border on code repetition, and that easily crops up errors, which is also what's nice about writing out this in a loop format would be that if you have another data set which has 5 unnamed columns that you want to delete, then you just set this number to 6 or 5 actually, sorry. Yeah, so generally I would write things in loops or list comprehensions when it's possible, and it just makes code easier to maintain and update, and gives less room for errors. Okay, so now we have this data set, and this variable name is sort of ugly. It's called unnamed form, and when in reality it should be called municipality. I know there's also all Denmark and regions, but we're also going to delete them later. The easiest way to rename columns in pandas is to use the rename method, and then you're using a dictionary where the keys are the old names and the values will be the new names that you want instead. And then you can have one like in here. So you're saying rename, and then I want to rename the columns. I want to rename unnamed form to municipality. You could have multiple names here, and then we use the in place equal to sort of change the original input data set. So now we get municipality here. There's another thing that it's allowed in Python, but typically you don't want your variable names to be a number and only a number. This can also cause a problem if you transfer the data set to another programming language. And it can also be an issue with some pandas functions. An easy way to change this is just to have it be a number still, but with some sort of prefix. So we want to make a dictionary, and we can do that in a loop. Where we're looping over the available years, and then we're updating this dictionary. A different way to do that would be to use list comprehension, but with a dictionary, which would look like this. Group. So this sort of, it gives the same answer. This is just a one-liner instead. Because you can use list comprehension on list, but you can also use the same approach using dictionaries. Yeah, okay, so now we have this dictionary that we can use to rename all these old column names to new ones. And now that's done. Another thing, sort of a convention you should never do, is to use white spaces in columns. Again, it's allowed in pandas, but it's not recommended. The main thing here in Python is that you can no longer use dot notation, which we have talked about. So right now I can write impl.impl 2008, which you wouldn't be able to do if there was a space in the name. But it's also just like uncommon practice. What you could do instead generally is to use underscores. And now we can sort of do extract using log and logical index. So this is that the municipality has to be equal to Copenhagen, and then we get a series of those values corresponding to that. So this is the employment rate for Copenhagen from 2008 to 2021. And then we have this thing I told you about, that this data set actually also contains regions, provinces, and one observation called all Denmark. So we want to drop that, so drop them. So we create a logical using this dot string, and this is because municipality is a string column or column with string values. And then you can use this. So if you're using dot string, has like a bunch of different functionalities. Like if you can think of some operation you can do on a string, then Pandas probably has it. This one is an easy one. It's called contains, and it tests whether the string contains the string region. So for example, that would be region hovedstaden contains region. For example. Yes, and sort of string has a lot of different spaces. You can remove all white spaces. You can make it all capital. There's like a lot of functions. So don't be afraid to Google functions with this string optionality in Pandas when you need to do some operations on strings. Okay, so let's see how this looks. Now we have all the rows that contain Denmark and province or region in their name, and now we can delete them. And one way to do it is to sort of delete using this. You just define a new data frame, say that's equal to the old data frame, but where our logical index is equal to false. So this is where it's equal to true, and when it's equal to false, it will be all the other observations. And yeah, once you start dropping observations, it's often a very good idea to reset the index if you want to use the index for anything. As long as we have this sort of numerical index, then it's pretty nice that it's ordered. Because as you can see here, now it's probably suddenly starting from 3 instead of starting from 0. So we reset the index using the reset index method. A lot of Pandas methods are sort of called what they do, which is nice. So it's easier to read code, even though you may not be able to remember all the functions. And you use the in place equals to true, and then you say drop equals to true. And if you don't say that, then Python will sort of make a new variable in your dataset with the old index values. And then we're not really interested in that because we just had an old numerical index. Sometimes you have an index with actual information. A easy way to get sort of a bit knowledge about some knowledge about your data is to use the describe method. Just data frame.describe, and then it's sort of for each variable will create a count of how many observations you have that are not nonce, mean, standard deviation, the minimum value, so it's for all numerical variables that you have. Minimum value and percentiles and the maximum value. And it's a bit overwhelming to look at, but it can be nice sort of if you don't know what's contained in your data set. And it can also be good to look at these min and max to see if there's something weird in your data set. And it's also nice to look at the count to see if you have sort of missing values somewhere in your data set where you're not supposed to have them. And you can also make descriptive statistics that are sort of chosen. So this is just showing only the mean, and sort of Pandas has a lot of the same functionalities that NumPy has. So you'd also be able to show the median, percentile, standard deviation, some stuff up here, stuff like that. This is very base statistics, but it's just to let you know that that's where you go from there. So we need to move on to long versus wide data sets. So what we've been looking at so far has been a wide data set. And whether you want a wide data or a long data set is sort of depending on what you're doing, basically. To understand what the difference is, you have to think of a data set having an ID. You don't have to, but you can think of a data set having an ID variable and a period variable. So sort of here the ID is municipalities, that's sort of a unique identifier. And then you have a period variable, which are the years. How many years are there? In a wide data set, then you have ID for one ID for each observation, one observation per ID, and then you have multiple variables per period. And that's a nice way to show data set, especially if you only have one variable. One of the problem is, for example, if we both have employment. Okay, so this is the data set. If we both have employment and GDP or something, then you would need to have twice the amount of variables in here, because you needed one called Impulse 2020 and one called GDP 2020. And that's where a long data set comes in. So in a long data set, then you have one row in the data per unique ID and unique year. So for each ID, then you have all the years as rows. So you have Copenhagen, and then you have 2008, 2009, 2010, so on. And that's how a long data set would look. I mean, both are nice depending on what you're doing. I think it's more common to have long data sets and be working with long data sets, in my personal experience. And it's always possible to switch between the two types, and Python pandas has a function that helps you do that, and the function sort of assumes that if you're going from wide to long, then you have this sort of formula where all your variables that you have in years, the values that you have, that their names are sort of a name called a stop name, and then the period, or sort of the counter that you have on the side. So this is stop is Impel, and the counter or the period is 2008. Yes, and if it's not like that in your data sets, then I think the easiest thing to do would be to rename those names using a dictionary, and then go back to this wide to long function. So yeah, let's just relook at our data set to remind ourselves how it looked. And now we want to make a long data set, so we use the wide to long on this Impel. We tell him what the stop names are. You can have multiple if you sort of have the GDP also. And then we say our ID variable is the municipality. And then we say that our period variable, we want to call that year. So that's just a name we chose. It just sort of has nothing to do with the data set so far. And then Python reverts the data into a long data set. And it's sorted by year first. So right here it looks like we only have the year, but you can sort of, if you use the sample instead of head, then you can see that we have all kinds of years. And you can also sort the values. It's another function. So see, I think it's a bit clearer how it looks if you municipality. Sorry, it's the index. So that doesn't. It was just because the variables are indices now. That we turned it into a long data set, so we sort of have to sort the index and not sort the values. And then you can see for OpenRAW, then we have 2008, 2009, 2010, 2011, 12, and so on. Then you have Eru, and then you also have yearly variables. Okay, cool. And the index is now a multi-index. So it sort of looks like this because it has like 2 layers in it. It has year and it has municipality. And you can access a multi-index using .x. Then you sort of say the value you want Roskilde, and it's the level of the municipality. You sort of akin to this. So now we get out all the values which has Roskilde. Akin to this, you can sort of say input to long, and then you can say 2008, and you're looking at year. That might have to be Miracle, yeah. And then you get all the municipalities for 2008. Yeah, you can also use log still. You just because you have to look at the index and not a variable, then you sort of have to extract the index. You can do that by taking input.long.index, and then if you want to look at municipality, the municipality level, then you say get level values municipality, and then you find all the rows where it's equal to Roskilde, and then you get the same information as above as you did with this X. I think an easier way to do it was to just to reset the index. If you don't want to use, I mean, there are some good multi-level index functionalities, but I wouldn't worry about them too much so far. Okay, so you can just reset the index with the method we had seen previously, and then you get the index as variables as you had before. And now we can sort the data set using .sort values, and just choosing the column names that we want to sort on. For example, like this. Yeah, and as you can see, the index after we've sorted has also been completely muddled around. But we don't worry about that too much right now because we're not going to be using the index. And now I want to show you a few plots just to let you know how it works in Panda Data Frame. It looks a bit different, but underlying is still Matplotlib, which you have already seen. And you can also, the thing I actually do mostly in practice is just to sort of extract the Panda series and then plot them directly. But you can also plot directly from a data frame like this, for example. So if we make a sub data frame which is only Roskilde observations, then you can sort of say the data frame dot plot, and then you can choose an X and a Y column, and then you can get a line plot out of that. And like there are a bunch of sub options that you can sort of go into. This is very unreadable, but if you Google pandas plot, then you can find more options, and it has a lot of the same options as Matplotlib, so you can also try around a bit, and you can do this interactively. Just to show you a small example, so this is a function which does what we've just done, sort of select a municipality, and then from a data frame for only that municipality, we want to plot the employment rate over a year. Yeah, and we create this function, then we put it into a widget with a drop-down menu for municipality, and then we can sort of click and point what we want to look at. Go to Copenhagen and sort of see, okay, after the financial crisis, everything went down. But enough, then we had a recovery, then we had Corona, and then we had sort of a weird thing while we still had Corona. And it's sort of the same for all the different municipalities. Again, which is sort of nice when you're in a notebook to sort of explore data physically, but you of course can't really put them into papers and can't put them into many assignments except from assignments in this course. But they can be good for exploration. Now we'll read in another data set, which has also been downloaded from Danish Statistics website. It's a data set of income for different municipalities, and it's very similar to the other one, so we can sort of use some of the same options we have used before. Now we just write it up a bit quicker, or doing it in one code block. So we read it in first, we skip the first rows, we drop the first columns, and we rename one of the columns to municipality, and then we also rename the numerical columns with the years. We drop all rows with missing values. So this is just drop nar, then you're just dropping rows with missing values. And then we remove the non-municipalities, so the region, provinces, and all Denmark. I think to notice here, which is written better than here, when we drop, so written better than here. So you can see here there's a lot of code repetition, and generally we don't like code repetition because it sort of makes room for human errors. In this case, it's not that prone to errors, but it makes room for human errors in some cases. And it's also just annoying that if I found out that, okay, there's also the region, provinces, there's also cities in this data set for some reason, I have to delete cities, then I sort of have to create an entirely new line and call it cities, blah, blah, blah. So here it's written a bit nicer in a loop, where if I found out I had to write in cities, then I would just do it like this. So you do it in a loop where you have I, and then you drop all of those values. Another thing that's done a bit differently here is that you're using the .drop method, and notice there's no access argument here, so we're not dropping columns, we're dropping rows, and we're dropping the index of all the rows where this logical operator is equal to true. So now we were in the income data set. But yeah, it's the same that's happening. And now we get this data set out. And this is the data set of sort of average incomes for, I think it was high educated workers in each region or each municipality. And then we can convert that to a long data set here. And here's another data set with areas in square kilometers. Also from the Danish Statistics website, and we're doing some similar stuff to it here. It didn't have, so you can sort of look at them physically. And in this data set you don't have the annoying starting columns, so we don't have to delete those, but we still have to rename some columns and drop rows with the missing values, and only keep municipalities. I think one thing you could do in order to avoid rewriting code would actually be to rewrite this into a function and then call that function on both data frames. One issue with that is that they're slightly different. So actually all these lines you don't have to do on the second data set, for example. But you could write an if condition to avoid that. That's sort of, this is where it gets, generally we want to avoid code repetition. But there's this blurred line between when two operations that you want to do, are they similar enough to just sort of have a general function that does them both, or are they distinct enough that you don't mind rewriting some code to have it? I think in this place it's a bit blurry. It's not that many lines of code, so maybe it's not a problem. Yeah. Now that we have created all these nice data sets, we of course want to save them so we don't have to run this entire notebook every time we want to access our new nice looking data sets. And to do that you use pandas functions or pandas methods, which are just called to and then the file type you want to send them to. So again you can send them to CSV, SAS, Excel, Stata, Pacret, and so on. And there you just write sort of the folder you want to go to and the name and the file type. Sometimes you have to write the file type in explicitly even though you already written it in here. Here we set index equal to false for all the rows because the index doesn't matter for us, so it doesn't make sense to have it saved already. Yeah, so today we sort of been looking at how you load a data set, how you clean it, look at it, and how you save it. There's like a rule called dry, don't repeat yourself. I haven't been mentioning dry, but I've sort of been mentioning that you shouldn't repeat code. And this is because when you sort of have a lot of code that you copy and change a bit in, then it's repetitive code, it's annoying to look at, but it's also like very error prone, because if you need to change something then you need to change it everywhere, and if you have a lot of lines of code that's sort of very manual code, then it's harder to look at exactly what's happening, and errors can very easily crop up, so try to avoid that. If you can pack stuff into a function, then that's mostly always better. Yeah, so whenever you have sort of operations that are extremely similar, or you're doing the exact same thing twice, just new data sets or to new variables, then you should use functions. Yeah, or loops or list conventions or something. Yeah. So thank you for watching today. I hope you enjoyed it.